Welcome learners. My name is Dr. Kapil Ishwan Sagar, Assistant Professor in Physics, Department of Physics, Ganpat Parsikar College of Education. Course entitled Everyday Physics with Demonstration, and the topic is Unlocking Secret of Atoms. So we'll start with section Unlocking Secret of Atom. Democritus was a dominant figure in the development of atomic theory of the universe. He theorized that all material bodies are made up of invisible small known as atom. Aristotle famously rejected atomism on one generation and corruption. Aristotle refused to believe that the whole of the reality is reducible to a system of atoms, as Democritus said. As it turned out, though Democritus was right. Dalton atomic theory. Sir John Dalton wrote the first atomic theory that all elements are composed of tiny invisible particles called atoms. Atoms of the same element are identical. Atoms of any one element are different from those of any other element. All atom of different element combine in simple whole number ratio to form chemical compound. In chemical reaction, atoms are combined, separated or rearranged but never changed into atoms of other element. Dalton was wrong about all the elements of same type being identical. Atoms of the same element can have different number of neutrons, therefore different mass number it can have. These are known as isotopes. Frederick Soddy. Frederick Soddy proposed the idea of isotopes in 1912. Isotopes are atoms of the same element having different masses due to varying number of neutrons. Soddy won the Nobel Prize in Chemistry in 1921 for his work with isotopes and radioactive elements. The billiard ball model proposed by Sir John Dalton in 1804. This theory proposed that matter was composed of small spherical particles, but evidence was later gathered that matter was composed of even smaller bit. A new evidence. During the 1900s, evidence was discovered regarding charges. Atoms have positive charge, discovered by Sir Rutherford, and negative charge, discovered by Sir Thomson. Charge interaction. So as you can see on the screen, that positive and positive charge repulse with each other, negative charge and negative charge repel each other, and positive charge and negative charge attract towards each other. As a result, revision to Dalton's model had to be made. Thomson's plum pudding or chocolate chip cookie model. Using available data on the atom, Sir J.J. Thomson came up with the idea of having charges surrounded with Dalton's billiard ball. Also used cathode ray experiment to discover the existence of electron. So you can just see you have a positive charge and you have a negative charge. Discovery of the electron. In 1897, J.J. Thomson used the cathode ray tube to discover the existence of negatively charged particle, that is electron. Cathode ray, so these are the conclusion from the study of the electron. Cathode ray have identical property regardless of the element used to produce them. All elements must contain identical charged electron. Atoms are neutral, so there must be positive particle in the atom to balance the negative charge of the electron. Electrons have so little mass that atoms must contain other particles account for most of the masses. Nuclear model. Ernst Rutherford discovered a huge flaw in the previous concept of atom during his now famous gold foil experiment. Okay. In gold foil experiment, we have a source of alpha particle and we have a thin gold foil which is exactly parallel to the source, and we have a fluorescent screen which is in a circular path around the thin gold foil. A source of alpha particle is incident on a thin gold foil, and there is a scattering of particle. So most of the beam is going parallel, okay. Some are scattered, most of the particle are in undeflected. Means the source which produces alpha particle is directly passing through the thin foil which is undeflected. The discovery of the nucleus and the positive proton summarize atoms are made of mostly empty space. Didn't know about the neutrons. Famous gold foil experiment. The Rutherford experiment was designed to prove Thomson's model of matter. Since Thomson proposed a model where matter was made out of atom that fulfill almost all the space available with a positive charge. The goal of Rutherford's experiment was to fire positively charged particles to study the scattering and the test model. So this is the gold foil experiment. The particle, again I will repeat this, the particle shot through the thin sheet of gold. Most shot went straight directly through the gold foil. A small amount were deflected, therefore the atom must be made of mostly empty space with a small dense nucleus. If previous model were correct, alpha particle would have passed straight through the gold, like this. In the following picture, there is a target hidden by a cloud. To figure out the shape of the target, we shot some beam into the cloud and recorded where the beam came out. You can figure out the shape of the target. Can you figure out the shape of the target? So you can just see the target 1. Okay, so consider that these are the alpha particle which is directly shot on the target material. Okay, and you can just see the ray 1 is coming, hitting on the other surface, it is reflected. Okay, again you have ray 2, ray 3 and ray 4. Okay, and you can just see in the target 2 you have a ray which is incident and it is reflecting in most of the randomly oriented. Okay, you can just see. Can you figure out which shape of the target? Okay, so target 1 you can just see it's a triangular, okay, and the randomly oriented is a spherical target. Nuclear model. Rutherford found that most, means around 99% of alpha particles that are shot at the gold were straight through it. From this experiment, Rutherford concluded that the atom had a dense positive core with rest composed of mostly empty space with the occasionally we can consider negatively charged electron. Rutherford finding. Most of the particles passed right through. A few particles were deflected, very few were greatly deflected. Conclusion. The nucleus is small, the nucleus is dense, the nucleus is positively charged. These are the references.